Hello. Before I dive into this example, I want to take a second and just bring to your attention the fact that you have a wonderful tool at your disposal called GeoGebra, which is an amazing piece of software. But what I particularly like about it is that you can come up with examples very quickly that you can then find the solutions to using the software. So you can do the math and then check your work. In fact, you can come up with a variety of problems just very quickly. So the example I'm about to do, which is going to be finding the distance of a median on a triangle, I didn't get the problem from the textbook. I just threw some points on the plane here, and I'm going to work it out from there. And you can adjust it. Oh, wrong tool there. You can adjust it, and you can change the problem however you want to make it easier or harder depending on the situation. Okay, so let's dive into the problem I'm about to do now. So the problem is find the length of the median from vertex A. So here's vertex A, and the median is the line made by connecting the vertex to the midpoint of the opposite side. So I can go on this and I can count the midpoint right off this. So remember, midpoint is finding the half of BC. But if I take a second and draw a picture here, I'm just going to come down and kind of simulate the rise over run of this. When we derived midpoint, we realized that since we're halving the length of a line segment, if we half the rise and half the run, we're going to end up at that midpoint. So if the rise is 2, half of that is 1. So I can kind of trace across here, dot, 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 and I end up there. And then the run is 1, 2, 3, 4, 5, 6. So we're going to travel 3, 1, 2, 3, and then I go dot, 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 dot. So there's my point right on the graph, which turns out to be 6, 3. So there's my midpoint, which is 6, 3. And so this problem is essentially, we need to find the distance between A to M. And A is the point 9, 7. Okay. Now, this one works out nicely, yes. So let's take a second. Imagine we didn't have the diagram here, or let's imagine we didn't have a scaled diagram so we couldn't read it off. What we could do here is we could first find the midpoint between BC by using the formula. So the midpoint between BC is going to be, well, we know B is the point 3, 4. We know C is the point 9, 2. So we're going to find the average of the two x points. So 9 plus 3 over 9, 2, 3, 4. I think I've messed up. Pardon me. 9 divided by 3 over 2. 4 plus 2 over 2. So that's going to give me the midpoint of BC as being 6. And 4, 5, 6, 5, 2 is 3, which is exactly what we have in the diagram. So therefore, this problem really becomes no more than finding the distance between AM, and so that's equal to the square root of, and now we're going to take the x components first, so let's say 6 minus 9 squared plus, now let's take the y components, so 3 minus 7, 3 minus 7 squared, so that's going to be the square root. 6 minus 9 is going to give me negative 3 squared, plus 3 minus 7 is going to give me minus 4 squared. Oh, and this actually works out beautifully because I see I have a 3, 4 triangle. So we have the square root of 9 plus 16, which is the square root of 25, which is 5. Couldn't have worked out better if I picked the numbers myself. So we know the length of the median from vertex A is 5 units. And kind of an add-on point, which is really nice to notice, is anytime you have a 3, 4 triangle, so we have one leg is 3 and the other leg is 4, the hypotenuse is 5. And that's a really nice triangle to kind of keep an eye out for, specifically on contests and more challenging problems. I hope that helped.